All right, so I'm going to talk about the greatest disasters of the least dangerous power source. My name is Bri. I'm a senior in computer science here. I'm going to be talking about nuclear power, even though the least dangerous power source sounds, I'll explain what that is and everything. All right, so really quickly, what fission is? Fission is when you add an extra neutron to a uranium-235 atom and it gets too big and unstable and it actually splits. But when it splits, an electron disappears and becomes pure energy. And that's all the power behind a nuclear reaction. Water is also good, and it's very important in nuclear reactors. The water acts as coolant, absorbs the heat, and also limits the amount of neutrons that crash into other uranium atoms to limit the reaction rate so that we don't get a runaway reaction. Finally, SCRAM, no joke, stands for Safety Control Rod Axeman. It's an emergency shutdown procedure because there literally was a person with an axe and there was a rope connected to the control rods, and if it went out of control, he was supposed to hit it with the rope with an axe. Can anyone tell me what this is?
Nuclear power plant.
Nuclear power plant, nice. Do you guys know which part of these are the reactors?
The domes.
The domes.
Yeah.
Nice. Well, yeah. No, it's the domes. Remember, this has changed. There we go. So those are the two reactors. There's two reactors. One of them is still functioning. The other had a partial meltdown on March 28, 1979. And so 3 Mile Island is the biggest and pretty much only commercial nuclear disaster in the United States. There was a partial meltdown, and this is the diagram. You can kind of see how that literally melted through part of the core reactor. And so 3 Mile Island was what's called a pressurized water reactor. And pressurized water reactors react in a specific way, which is the part of the water that flows through the reactor and gets heated up by the reactor is actually pressurized, prevented from becoming steam. And it travels next to an external loop that gets transferred, that the heat gets transferred to, which becomes steam and powers the turbines. So what happened? Essentially, operator error, bad user interface design, a button and a light that was indicated that a blow-off valve was leaking coolant. They just ignored it and they turned off the warning, and so they lost a third of their coolant before they realized what was happening. Can anyone tell me what this is?
Chernobyl.
Chernobyl. So Chernobyl is the worst nuclear disaster in history, and it's entirely human error and crazy Soviet shit. So in 1986, this was a boiling water reactor, and essentially boiling water reactor is slightly different in that the water, instead of being in a pressurized loop, actually gets boiled by the heat coming off of the reactor. And that steam goes into the turbine, this powers the turbine, and it condenses and goes back in. Now this is kind of problematic because if the water starts bubbling near the reactor core, then what happens is you don't have that water intercepting those neutrons, so it kind of goes out of control. And that's what happened. Poor operator error caused the water to start flash boiling next to the reactor core, and then it got out of control because as you lose water in a boiling water reactor, it gets worse. And then, so it blew off a 1,000-ton containment vessel, and then the Russians dropped a bunch of sand on it. And the sand was really heavy in graphite. It irradiated the graphite, the fire moved the graphite into clouds, and it spread across all of Europe. Then they built a sarcophagus, which is just a radiation containment vessel. A lot of people died building it. It took 206 days to build, and during that time it was leaking radiation everywhere, essentially. Finally, everyone probably knows what this is. Fukushima. This was actually a relatively modern design. It's also a boiling water reactor, though. And we'll see how that kind of led to the problems with Fukushima. If you can see up there, that's the design of the reactor. There's water around it to make sure that that doesn't boil. What happened with Fukushima was that they initiated SCRAM procedures. Everything worked functionally, unlike it did in Chernobyl, where the control laws never went down. But what went wrong was that boiling water reactors, even after they've been shut down, still produce about 7% of the heat that they used to due to something called decay radiation. And so you still need the cooling systems to be fully functional. And in Fukushima, they ignored all of the warnings that were previously submitted in reports that said, your seawall is not high enough, your generators will be knocked out by a tsunami of X height. They said that will never happen. Happened in 2011, and it was pretty much preventable, and a lot of people got fired in trouble with it. These are the death rate per watts produced of major energy sources, and you can see nuclear's over there. Coal that we use in the United States is 100 deaths per watt produced. Nuclear is 0.4. Coal in China is 287 deaths per watt produced.
Per watt.
Terawatt.
Thank you.
Terawatt. Thousands of people die for our gigawatt reactors.
1.21 gigawatts.